Chapter 10.1 reviews basic information about circles. A radius is a segment that has endpoints at the center of the circle and on the circle. For example, CD is a radius. Radii is a plural of radius, and in this diagram there's radii CD, CE, and CF. A chord is a segment that has both endpoints on the circle itself. For example, AB is a chord. So is DE, but DE is a special chord because it goes through the center of the circle and it's called a diameter. So a diameter is always a chord is sometimes a circle. In the first problem, it asks us to name the circle and identify a radius. To name the circle, we have to use correct notation. So this is circle E, and we use this notation here to name the circle E. There are two radii pictured here. We could state that a radius is ED or EB. In problem B, it asks us to identify a chord and a diameter of the circle. So for chords in this picture, we have XZ, WY, and WZ. Of those three chords, two of them are diameters. XZ and WY. Next, we're asked to name the circle and identify a radius. Well, the center of the circle is F, so it's called circle F, so we can rule out D. Looking at A, AT is a diameter and not a radius, so A is out. FN is a radius, so the answer would be B. If you look at answer C, it would be AC, which is a chord, so that wouldn't fit. Problem B asks us what segment is not a chord. AT is a chord, also a diameter. CT is a chord. FN does not have endpoints on the circle, except for one of them, so FN is a radius. So the answer would be C. Now TN, which is right here, is also a chord. The radius is half the diameter, and the diameter is 2 times the radius. In this problem, they give us that RT is 21 centimeters. RT is a diameter, and has asked us for the length of QV. And QV is a radius. So QV would be 1/2 of the diameter, which would then be 10.5 centimeters. If QS is 26 centimeters, what is the length of RV? It would be half of QS, which would be 13. Circles are congruent only if they have congruent radii. And if two circles have congruent radii, then the circles themselves are congruent. All circles are similar. Concentric circles have the same center point, but different radii. To do a problem like this, I would mark as much information as you can, and then determine what you need to find. This tells us that the diameter of circle X is 22 units. XZ would then be the the radius of circle X, so it would be half of 22, which is 11. They give us that the diameter of Y is 16 units. WY here is the radius, so that would be half of 16, which is 8. They also give us that the length of WZ is 5. And I want to find the whole entire length XY. So this is what I want to find. If I add 11 plus 8, which gives me 19, I have counted WZ twice, once in the 11 and once in the 8. So I would have to subtract it, which would give me 14 units. The diameter of circle D, as it says respectively, so the diameter of circle D is the first one listed here, which is 4 inches, which gives us that DC, this length right here, is 2. They give us that the diameter of circle B is 9 inches, so the diameter of this circle is 9, and also the diameter of the larger circle is 18. They ask us to find the length of AC. So from D to A, that length is 9. From D to C, that length is 2, and we want to find this length right here. So 9 minus 2 equals 7 inches. This is something we've already covered in class. The circumference is pi d, or circumference is 2 pi r, because d does equal 2 times r, 2 times the radius. A series of crop circles was discovered in Canada on September 4th, 1999. The largest of the 3 circles had a radius of 30 feet. And it's asking us to find the circumference. So circumference is 2 pi r, which is 2 pi times 30. The exact answer would be 60 pi feet. If I put that into the calculator and round it, I would get an answer of 188.50 feet. I want both the exact answer and the rounded answer. So both answers. The exact answer is 60 pi. There's no decimals in it. The rounded answer is 188.50 because I'm rounding the number of decimals because it'll go on forever with the decimals. Here it gives us that the diameter is 120 feet. And we want to find the circumference. So since they give us the diameter, I'm going to use pi d, which gives the exact answer that it's 120 pi feet. Putting that in the calculator, I get a rounded answer of 377.0 feet. The next type of problem we're going to look at is a problem where you work backwards. You use the equation, you work backwards, and it's asking you for 2 things. It's asking you to find the diameter and the radius. Whichever one you find first, if you find the diameter first, you divide it in 2 to get to the radius. If you find the radius first, you're going to multiply it by 2. So I would use your calculator to find the rounded answer and leave it in the calculator and multiply that by 2 or divide by 2 and then do your rounding again. So for this one here, if we find the diameter first, we're going to use the formula circumference equals pi d. So circumference, which is 65.4 feet, equals pi d. Divide both sides by pi, and I would come up with an answer of 20.82 feet for the diameter. Now I would have left that whole entire answer in the calculator and then divided that answer by 2 and round again, which would give me 10.41 feet. In this case, it looks like if I just kept this original answer that I could have just divided it by 2 and it would have been okay. Sometimes that works, sometimes it's a little bit more picky about how many decimals you go out. So 20.82 feet, and the radius is 10.41 feet. Find the radius of a circle to the nearest hundredth if the circumference is 16.8 meters. So circumference equals 2 pi r. 16.8 equals 2 pi r. divide it by 2 first, so you won't make a common calculator error. Give us 8.4 equals pi r, and then divide by pi, and your answer would come up to be 2.67. You can definitely do 16.8 equals 2 pi r, then divide by 2 pi. But when you put this into the calculator, you have to be very careful that you put parentheses around the 2 pi. Otherwise, you'll do 16.8 divided by 2, which gives you 8.4, and then multiply it by pi, because it's using the order of operations. For the next problem, I want to find the exact circumference of circle K. I'm going to call this point A here, and this point B here. KA and KB are both radii, which would give us that they're equal to each other. So if the two sides of a right triangle are equal together, we have a 45, 45, 90, which would make this A, and this A rad 2. So using that, it gives us that the radius is 3. So each side here would be 3. So circumference is 2 pi r. So circumference is 2 pi times 3, which gives us the exact answer of 6 pi. Once again, we need to find the radius on this one. We know that the hypotenuse here of this triangle is 10. We know that this leg and this leg are equal to each other, so it's a 45, 45, 90. So A rad 2 would equal 10. So A equals 10 divided by rad 2. Rationalize, which would give us 10 rad 2 over 2, which is 5 rad 2. So we determine that the radius is 5 rad 2. So circumference equals 2 pi r. Circumference equals 2 pi times 5 rad 2. 2 times 5 is 10 rad 2 pi. The remaining problems in the handout are extra problems that you can use to study for a test or a quiz.